So we're looking at exponential functions. Y equals a to the power of x is called an exponential function to base a, and a cannot be 0. So when a is greater than 1, we have exponential growth. So the features of an exponential curve are that if a is greater than 1, the graph is increasing with the shape. It goes through the points 0, 1. All exponential curves, no matter what the base is, go through this point 0, 1, because if you think about it using our indices knowledge, anything to the power of 0 equals 1. And it goes through 1a. And I've also marked on the point -1 to 1 over a, because if you think about it, if we were to substitute in a to the power of -1 using our negative indices rules, we could rewrite that as a positive index as 1 over a. You'll also see that it approaches the x-axis as x tends to negative infinity, but it will never reach the x-axis and it will never go below the x-axis unless there's a transformation applied. So the x-axis acts as an asymptote. If the value of a, our base, lies between 0 and 1, the graph is decreasing with the shape. And so it goes through 0, 1 and -1a. And I've also plotted on that point 1 over a, because we've reflected it in the y-axis. And when the value lies between 0 and 1, it's a bit like plotting y equals a to the power of -x. So as it approaches the x-axis, this time it's as x goes to positive infinity rather than negative infinity. And again, our x-axis is an asymptote. So we want to consider the key points to work out this first example. The graph below has the equation y equals a to the power of x, and we want to find the value of a. So the first thing we're going to do is we're going to consider the key points. And the key points of our curve are 0, 1. So if we've got f of x is our normal a to the x function, it would go through 0, 1 and 1a. Now we want to know what's happening with this function. And for this function, it's going through 0, 1, but it's going through the point 1, 5. So this is our y equals a to the x function. And you can see that we can equate that a and the 5 to each other. And so a is going to equal 5. So our curve would be y equals 5 to the power of x. For the next example, the graph below has the equation y equals a to the power of x plus b. And we want to find the values of a and b this time. Now that plus b is a horizontal transformation, either up or down the y-axis. And so it's easier to find the b value and then undo that transformation to work out what the a value is. So again, we need to think about what our function y equals a to the x would look like, and it would be normally going through 0, 1 and 1a. And because we've got 2 something, it would be 2a squared. Now, you can see that with this particular curve, we have it going through 0, 3. So that means that we've got a horizontal shift that's 2 up. So our b value is going to equal 2. Now, if we undo that value and we compare that to 2, 4, because we've taken away that upward shift of 2 from that y coordinate, we can now make a squared equal 4. Now obviously when we would normally square root, we would get a plus or minus value, but remember a has to be greater than 1 in order for this to be an exponential growth. And so we can say that a equals 2. So the equation would be y equals 2 to the power of x plus 2. And our a value is 2 and our b value is also 2. Now it's possible to sketch related graphs for exponential functions by considering the key points. So we want to sketch the graph of y equals 4 to the power of x minus 2. So this time we're going to have f of x, and normally for a 4 to the power of x curve it's going to go through 0, 1 and 1 the base, and this time the base is 4, so it's going to go through 1, 4. Now I want a horizontal shift of minus 2, so that means that my y coordinates are going to shift down by minus 2. So for my f of x equals 4 to the x minus 2, my points are going to become 0, negative 1 and 1, 2. And where my asymptote on a 4 to the x curve would be the x-axis, my asymptote is going to be at negative 2 for this particular curve. So if I just plot that asymptote in, it will help me draw my curve. And then I'm going to plot on the points that I want to go through. So I know that I want to go through 0, negative 1, and I'm going to write that on. And I know that my graph's going to go through 1, 2. So I'm going to plot that one on. And then I'm going to sketch in my curve. So it's approaching negative 2, but it's never going to reach it. And it's going to go through those 2 points. And I'm going to label it as y equals 4 to the power of x minus 2. So my final example, I want to sketch y equals 3 to the power of negative x plus 1. Now that x plus 1 in a bracket is a vertical shift, and I need to remember that x plus 1 means it's a vertical shift left by 1 unit. And I've got a negative in front of that bracket, which means it's going to be a reflection in the y-axis. However, with exponential functions, we can just plot in those points, remembering that the shape is going to be a decreasing function rather than an increasing function because of that negative value. So if we consider the points on our y equals 3 to the x curve, it would be going through 0, 1 and 1, 3. However, we want to plot in some points, remembering it's going to be a decreasing function as x tends to positive infinity. So, if we were to say we want to know what the coordinates at x equals 0 are going to be, if we plot that in, so y equals 3 to the negative 0 plus 1, that's going to give us 3 to the negative 1, and we know that we can rewrite that using our rules of negative indices as a third. So we've got the point 0, a third, so that's where it's crossing my y-axis. If I consider the point x equals negative 1, again, y equals 3 to the negative 1 plus 1. That's going to give me 3 to the power of 0, and I know that 3 to the power of 0 equals 1. So this coordinate is going to be at negative 1, 1. So I can plot that in at negative 1, 1. And if I just consider x equals negative 2, so that it will help me with the shape of my curve, I've got y equals 3 to the negative 2 plus 1. So that's going to give me a value of 3 to the power of 1, which is 3. And so we can plot that point on at negative 2, 3. And then we just want to sketch in our curve going through these points, and remember we're tending towards the x-axis as x tends to positive infinity. And finally we just need to label our curve as y equals 3 to the negative x plus 1.